Good morning. How are you doing? Oh, very good, very good. I've been here all week speaking, and what's nice is sometimes we want to talk about code. We want to talk about curly braces and semicolons and implementations. But on a day like today, when we talk about architecture, it's wonderful talking at a much higher level and talking about how these pieces fit together rather than getting bogged down in implementation details. So that's what this talk is going to be, a talk about mean architecture. My name is Scott Davis. For years I ran my own consultancy called Thirstyhead, which is where you'll find all these slides and everything else, thirstyhead.com. But I recently signed on with ThoughtWorks. So I am pleased to be a principal engineer with ThoughtWorks, and that's where you'll start finding additional information from me. But currently, it's all up at thirstyhead.com. So, how many of you are working with the mean stack right now? Oh, very good, very good. Are you enjoying it? Oh, good, good, very nice. Haha. The mean stack, of course, is a nice combination of technologies. So, if you look up mean, it comes up as saying that this is MongoDB for your database. This is Express.js for your web server. This is Angular.js for your web framework and Node.js for your execution environment. But the really nice thing about mean is it's really meant to talk about a style of architecture, not the individual pieces. So if you swapped out, say, MongoDB for Couchdb, I wouldn't call it a scene application, right? It'd still be mean, you're just using a slightly different implementation. If you were using, say, Happy, a web server, HAPI, if you're using Happy.js instead of Express.js, you're still absolutely doing mean style development. So sometimes it's helpful to visualize what we're talking about here. You're familiar with the LAMP stack, yeah? LAMP is what we were doing in the last century, right? In the 20th century, we were focusing on Linux as our operating system, Apache as our web server, MySQL as our database, and then Perl or Python or PHP. And again, those are for examples of the software we're using, but really, we're here to talk more about architecture than implementations. So when we consider the LAMP stack from an architectural perspective, we see that everything is going on server side. The browser isn't even represented into this document because it's really not important, right? Since all of the important stuff has gone on server side, when you put the response on the wire, you're kind of thinking to yourself, I don't really care where it goes from here because I've done all the interesting work. I'm not agreeing with that point of view. I'm saying that point of view represents a LAMP stack architecture mentality. And the beautiful thing is, this is still a valid architecture. We can still do everything wholly server side. But we're going to find that if we continue down that path, we're going to be a little bit out of step with modern software practices. And many of the modern frameworks that you want to use, whether it's Angular or React or Ember or Polymer or any of these kinds of frameworks, you're going to find that they're out of step with this mindset as well. So as we move over to the mean stack, and remember A was the Angular or React or Ember or Polymer that I'm talking about, you're going to find that these apps lend themselves really nicely to single-page apps. And single-page apps, by their very nature, move some of the responsibility down to the browser. In the LAMP stack, you're doing all of your MVC server-side, model view controller, servlets and JSPs or ASPs, yeah. Whereas in a mean stack, your controller and template and business logic lives down here in the browser. In fact, the only time you round trip to your server would be for things like authentication and for database access. Yeah? So I've written about this type of architecture for years. If you're interested in learning more about it, I wrote for it extensively for IBM Developer Works. If you look for an article series called Mastering Mean, you'll see a whole long write-up on how to build applications that are shaped like that. I've also done a series of videos for O'Reilly. If you're an O'Reilly customer, especially if you have a Safari online account, you can see mean stack architecture, and you can see various videos I've done discussing this. But our topic today is mean 2.0. And just to thoroughly confuse you, I've been calling this kind of third wave web architecture. Because this is what we're going to talk about today. And I think this is what's incredibly interesting from an architectural and from a technology perspective. Because what we have now is your entire application down in the browser, including the database. Recall that before the database was still server-side, but now we have the entire application client-side, and we have the entire application server-side, and they're constantly synchronizing amongst themselves. This is a really interesting way to build out applications. Because when we start talking about things like mobile first, well, this lends itself very nicely to that, right? Mobile, everything's going on there. But if we start saying things like offline first, this architecture doesn't lend itself nicely to offline first. As you cut that connection, as you sever that connection, you lose access to important authentication and business data. So we want to move to a scenario where your app lives entirely in the browser, which means it's not only mobile first, but it is offline first as well. Sometimes I affectionately call this the Heisenberg Architecture. Are you familiar with Heisenberg's uncertainty principle? Or excuse me, Schrodinger. I blew my punchline, didn't I? Rats. Schrodinger. You familiar with Schrodinger? The metaphor of Schrodinger's cat. When we're dealing with quantum issues, they are in both states simultaneously. So as a thought experiment, Schrodinger said if you put a cat in a box and sealed the box, couldn't see inside of it, then based on Schrodinger's theories and quantum theories, that cat is simultaneously dead and alive because you can't tell it's in both states. So in much the same way, Schrodinger's architecture here says your app is entirely functional when it's offline, or entirely functional when, say, you visit your website for the first time. Maybe when you visit the first time, you're completely hitting that server-side behavior. And then that server-side begins streaming the state of the application down to the client. And eventually, you transition to using that client where you can sever the connection completely. This is what we're going to discuss for the next 50 minutes or so. Any questions about this before we get started? Yes, please.
If there are multiple applications being deployed on the same client side, and then all of them are RAM heavy, so that's what I'm trying to understand. How would it work?
I think I'm going to answer your question. As soon as I'm done, you let me know if I succeeded, okay? These are three different kinds of architectures. I'm not suggesting that there's one true architecture to rule them all. What I think the interesting part of this is a well understood architecture, completely server-side. And if that's the appropriate architecture, we understand that. We've got design patterns and years of experience building that out. If you want to do something like this emerged a couple of years ago. So it's still fairly new. We're still learning a lot about it, but you do have patterns, you do have frameworks, you do have articles and books and videos that describe that. This third way of building on architecture is a new way. And as we go in and explore this, I think you'll see that it offers lots of interesting possibilities, lots of interesting opportunities. It may not exactly meet your needs, but understanding that we have this kind of architecture or this should help us make a more informed decision. Does that help?
Maybe I'll see the rest of the session.
Perfect.
And then it'll be better.
I think that's an excellent plan. All right. So this is what we're going to cover in the next little bit. And I was being clever. There are lots of hashtags running all over the place, right? So I decided that these would all be rallying cries. We can decide what our favorite hashtag is out of these. So maybe we like Mean 2.0 architecture because it's HTML first. Or maybe we like it because it's mobile first. Or maybe because it's one web, many screens, or offline first, or a progressive web app. You'll see these concepts are all interrelated to each other, but this all kind of gives us a better idea of what I'm talking about with that last architecture that we described, that third wave architecture, that Schrodinger's cat of architectures. So to begin, let's discuss HTML first. And this sounds odd because we're web developers. I should turn around and ask, how many of you consider yourselves web developers? Yeah, of course, many of us do. Many of us do. And this is what many people think web development is these days. And you look at that and say, oh, React, oh, I love React. Oh, except Angular's in there too. Yeah, I like Angular. Oh, Node, yeah. And, oh yeah, ES6, okay, that's good. Yeah, Webpack. What's missing out of all of this? HTML. HTML. The whole reason we're here is to write web pages, yes? And I bring this up because it's important for us to realize many of us have spent our entire lives as programmers. As a Java programmer, you're not going to do anything unless you're writing code. As an iOS programmer, you're not going to do anything unless you're writing code. As an Android developer, you're not going to do anything unless you're writing code. As a web developer, we really want to remind ourselves constantly that it's not 100% JavaScript that's going to get us down this path. As a matter of fact, if you do find yourself coming up with 100% JavaScript solutions, you're probably going to want to reconsider. You're probably going to want to reconsider because the web is a three-legged stool. It is HTML and CSS and JavaScript. And anyone argues that one is more important to the other, or only the leg of the stool we should be focusing on, as you can imagine, is a fallacy. I worked on the Google Maps project, not with Google, but with a satellite imaging provider. We solved this problem many times. I've done a number of architecture, been an architect on a number of products that are Google Maps-like projects, whether they're using the Google Maps API or open source equivalents. But what I loved about Google Maps is they took a hard problem, a great big map, right? I mean, literally a map the size of the world. And how do we get that into a browser? How do we get into the browser efficiently? Oh, well, we take this great big image and we tessellate it. We tile it. We slice it up into 128 by 128 pixel blocks. And you know what? Once you take that image and break it into tiny little images, you don't need any JavaScript at all to do that. You're just making HTTP GET requests. Every tile has a unique URL, and so every tile can be cached on your client side, on every intermediary router, proxy. As you go up, it'll be cached by ISPs, it'll be cached all the way around. This is a simple HTTP GET. Now you're thinking to yourself, well, wait a second. I got all these tiles. How do I stitch them together? How do I get them so there's no visible gaps in between them? Oh, CSS. So we solved the imagery problem with HTML, but we're solving the look and feel problem with CSS. Where does JavaScript come in? Oh, on mouse down, on mouse move, on mouse up. JavaScript is there important for all the behavior, all the user interactions. But you'll see that's a tiny fraction of what we're dealing with. I did a talk for years called Roll Your Own Google Maps, and it took us 100 lines of JavaScript. 100 lines of JavaScript to handle something that had multiple zoom levels, that dragged around, double-click to zoom, all those kinds of things. Because JavaScript was one important aspect that gave us the slippy map aspect of it. But that, combined with the CSS to stitch the tiles together, and the tiles themselves, which were simple HTTP GETs, that's the whole solution. And that's brilliant. My hat is off to the folks at Google who came up with that, and it's a pattern that's been replicated over and over again. But that's what I mean by a three-legged stool. If you take the HTML or the CSS out of that, it doesn't work anymore. And if you try to solve it all in JavaScript, you're going to be writing an enormous amount of code that actually has very little value because you can solve it in more idiomatic ways. Does that make sense? Let me continue down this path then. Google has a project called AMP, the Accelerated Mobile Pages Project. What's interesting about AMP is that all JavaScript is forbidden. In order for you to have this accelerated mobile page scenario, you can use all the HTML you want, you can use all the CSS you want, but no custom JavaScript is allowed. Now you say to yourself, wait a second, there's no way that I could write an app like that. Well, you could in certain circumstances. There are a lot of companies out there, like the Washington Post, the New York Times, Wired is using AMP. And if you think about those kinds of news articles, that's text and images, it doesn't require any behavior at all. And so it was easy for them to do that. But whereas AMP pages don't allow JavaScript, they do allow web components. I've talked about that. These are encapsulated custom HTML elements. And those custom HTML elements can have HTML, CSS, and JavaScript associated with them. So the AMP project says we allow components, but don't allow raw JavaScript. And the reason they're doing this is for speed. That's the accelerated part of the accelerated mobile pages. And accelerated mobile pages are saying, you know what? Average load time for mobile sites these days is 19 seconds on a 3G network. Am I telling you anything you don't already know? I'm experiencing that same pain over here, yes? You know? Web pages take an incredibly long time, a painfully long time. So painful that 53% of mobile site visits are abandoned after 3 seconds. So we've got an interesting dynamic contrast going on here, some tension, don't we? That our pages are taking 19 seconds to load, but our end users have given us 3 seconds tops to accomplish that. The Washington Post publishes a case study about their AMP successes. And they say much the same thing. Nearly 55% of their traffic is coming from mobile screens. Over half of their traffic is coming from mobile screens. And over half of their customers will bail on them if that same 19-second, 3-second ratio held up. When they ended up using AMP, they publish over 1,000 articles in AMP every day. And their average load time is 400 milliseconds. Now let me say that again to let it sink in. The average web page, mobile web page, loads in 19 seconds. Their web pages are loading in a third of a second simply by eliminating JavaScript. I just had a client that I am not working with right now, but it was really funny because they said, Scott, we're really having performance issues. Can you come in and help us improve performance? Now, I don't want you to change our architecture, but I really want you to help us change our performance, okay? Is that even possible? No. And when we looked at his code base, their code base was JavaScript layer on top of JavaScript layer on top of JavaScript layer. You know what he was expecting me to do? Add more JavaScript to improve their performance. I said, no, we're going to do just the opposite. We're going to start peeling away JavaScript to the point where we could literally have no JavaScript and get you quarter second, third second page loads. When you start seeing the big names that are using this, New York Times, Washington Post, Wired, Huffington Post, Gizmodo, the list goes on and on. There are billions of AMP pages out there, and none of them use JavaScript. This should definitely be a legitimate consideration for you. I know it sounds like heresy, doesn't it? Am I even a programmer? Of course I am. But part of what I want to do is know when it's appropriate to use those superpowers and when those superpowers are in fact not superpowers, but a detriment. Let's discuss mobile first, because we went right to accelerated mobile pages. We went right to mobile page load times and things like that. I'm not going to ask any of you to embarrass yourself. I'm going to ask you to mentally raise your hand. You don't have to actually raise your hand. How many of you support a www website as well as an website, a mobile website? I'm not going to ask you to raise your hand, but I want you to feel the shame. Feel the shame inside. We can tell. We can tell you're doing that kind of thing. You're a bad, bad person for doing that kind of thing. Shame on you for doing that kind of thing. Okay. The only problem with that is in the last century, you were doing it exactly right. That's the bummer about this scenario, right? I built websites. I built a number of websites when this was state of the art. I remember my Motorola Razr. I loved that phone. It was also 2005. It was also a dozen years ago. And the reason why we had to build out websites, look at the specs on this. Oh, look at that beautiful 176 pixel display. Megapixels? No. Pixels. 176. If you had one pixel go out, you lost almost 1% of your pixels right there, yes. Oh, and look at the speed as well. 32 kilobits per second. Ah, yeah. State of the art, right? That is why we needed an website. You may think you've got this kind of architecture in place, right? But in fact, that's what your website was, right? A doggy door. Yes. So, we've got another more subtle reason why is such an anti-pattern. It's because link rot. We're in a world now where our mobile phone doesn't support 176 pixels. It supports thousands of pixels. And our tablets do as well. And if we provide separate URLs for them, it guarantees that every one of your users is going to have a terrible experience. Because if I find a really cool article on evolutionary architecture on my iPhone, and I send it to Neil, and Neil pulls it up on his tablet, and says, oh, this is great, Venkat would love this as well, and he emails it from his tablet to Venkat, who reads it on his laptop. We are guaranteeing that each one of us is going to have a bad experience. That's not what you want, is it? So instead, We want to have this philosophy of one web, many screens. And this is really my rallying cry. I try to say this in almost every web presentation I give. One web, many screens. Because that's what you need to continue to repeat to yourself. Not this. This is two webs. We want one web, many screens. We want one web that adapts itself to the appropriate device. And the way we do that is through responsive web design. It's a lovely book, by the way, Responsive Web Design. But it really can be summarized as, one website for all devices. This is the reality of the world we're in right now. This is what we need to design for. But maybe Bruce Lee can say it better than I can. Did you have any idea that Bruce Lee was into responsive web design? I didn't. But listen to this. He's talking about building your website. He says your website should be shapeless. It should be formless like water. When you pour water into a glass, it becomes the glass. When you pour it into a cup, it becomes the cup. When you pour your website into a smart TV, it needs to become the TV. When you pour it into an iPhone, it needs to become the iPhone. This is responsive web design in a nutshell. And it's absolutely achievable, isn't it? It's absolutely achievable. If you go to Starbucks.com, I encourage you to do that. Go to www.starbucks.com on your desktop and do the same thing on your smartphone. Do the same thing on your tablet. It's the same website, but it adapts itself. It responds to the device it's on and adjusts itself accordingly. Time Magazine is another great example. The examples go on and on. There are a number of them out there. But I want you to notice one important thing about these. What's the default orientation of a laptop screen? Portrait or landscape? Landscape. What's the default orientation of a smartphone? Portrait, yes. Now, smartphones are interesting because it supports both portrait or landscape. Laptops, if you pick up your laptop and turn it on its side, not the same experience, right? So when I come into an organization and I'm helping them evaluate how mobile first they are, I say, show me your vertical design comps. Show me your vertical design wireframes. Show me the artwork that your design department has produced that shows me what your website looks like in portrait mode. And that's a wonderful canary in the coal mine, because if they already have vertical designs, it means they're already thinking about mobile devices. And I've had designers say, well, can't we just make everything landscape? And I said, you know what? The JavaScript API that sends a shock to the user every time they try to look at their phone in portrait mode, that API doesn't exist, right? So of course they're going to expect to look at it this way. And if they look at it this way and they have a bad experience, are they going to blame themselves or are they going to blame us? It is our fault, isn't it? This statistic I find interesting. The first iPhone came out in 2007. The Android phone came out in 2008. So in 2010, we were on average spending just about half an hour on vertical screens versus 4.5 hours on landscape screens. Does that make sense? Now look as we progress every year. Has our time on landscape screens changed? Not dramatically. Has our time on vertical screens changed? Oh, you bet it has. To the point where now we're spending 1/3 of our time on portrait screens and 2/3 of our time on landscape screens. So do you think that we can design for 2/3 of an experience? That's to 66%. That's not even a passing grade, is it? We need to have designs for both because this is the reality of the world we're living in these days. So we hear mobile first quite a bit, and that's a wonderful rallying cry. And notice this is the newer one. We started to say it must be responsive, and that's important. And that's encapsulated in what we're discussing when we talk about mobile first. But why is mobile first so important? Why is it a rallying cry? Let me throw some statistics at you and see if you'll be convinced at the end of this. Smartphones started outselling laptops and desktops in 2011. They've been outselling desktop computers for quite some time. And I love this. It wasn't even close, right? Let's look at this a different way. Same time period, but just focusing on Apple. Apple sold more iOS devices in 1 year, 2011, than all of the computers they have sold in the combined history of the company. They sold more mobile devices in 1 year than they sold desktop computers in 28 years. And when you visualize this, they've normalized this to product launch, right? So this is year 0. And this green line is how long it took them to sell, say, 50 million Macs, about 21 years. That same line here, it took them about 4 years to sell 50 million iPod Touches. It took them about 3 years to sell 50 million iPhones, and it took them less than 1 year to sell 50 million iPads. So the numbers aren't as important as the slopes, right? As we see desktop graphs, they'll be fairly flat. They'll be going up, but fairly flat. When we start looking at comparable mobile statistics, they'll hockey stick. They'll be almost vertical. We'll see this chart over and over and over again. So, mobile sales are a big deal. Mobile devices are outselling computers on a regular basis, and it's not even close. How about traffic? In 2016, desktop internet traffic, and this is worldwide, desktop internet traffic for the first time last year was surpassed by mobile traffic. Not by much, but surpassed. So we're now seeing that smartphones are outselling desktops. We're seeing that usage is outpacing desktop usage. I mentioned this yesterday. Do you know what the most installed operating system is worldwide? It was Windows up until March of this year, just last month. Android surpassed Windows in terms of installed base. So Android is the most popular operating system in the world right now. Google uses the mobile experience to index your website now. Because we are in a mobile-first world, Google looks for the mobile website in terms of speed, in terms of layout, in terms of behavior, to build out the Google index. If your website is too slow on mobile, you will lose PageRank. Google feels that we're a mobile-first world right now. This is usage patterns for a number of popular websites. The orange bar represents the percentage of mobile traffic they receive. The blue bar represents the percentage of desktop traffic. Facebook, about a third of their traffic comes from desktop, 2/3 comes from mobile. Twitter, over 3/4 of their traffic comes from mobile. Instagram, virtually 100%. Vine, virtually 100%. Pinterest, virtually 100%. We begin seeing this constant pattern repeated. Does this feel like I'm building up arguments for having a separate M.dot website? It may be making arguments that you should drop that www website, right? Keep the M.dot, throw away the other. Yeah. In 2012, 1 billion people, that's billion with a B, right? 1 billion people used mobile as their primary way to access the internet. I can speak to this directly. I go around from university to university in the States. I've been to Iowa State. I've been to Penn State. I've been to Yale. I mean, the list kind of goes on and on. In each case, they're saying, we need to build out all of our services to be mobile friendly. I said, really, why is that? They said, well, at Yale University. Yale, one of the most prestigious universities in the United States. Incoming freshmen are no longer showing up with laptops. I said, you're kidding me. He said, no. Incoming freshmen are saying, oh, my roommate will have one. Or we got a computer lab here. Oh, we got an internet cafe down the street. I just need it for writing papers anyway, right? And so, yeah, I'll be fine without a laptop. How many incoming freshmen to Yale do you think showed up without a smartphone? 0%, right? So Yale has said, oh, our customers are telling us they need to be able to register for classes on their smartphone. They need to be able to get their grades. They need to be able to communicate with their professor. They need to be able to add money to their cafeteria plan. They are mobile first. We saw it starting at the universities, and now it's sweeping through the general web population. Because I keep getting more white hair in my beard, but there's more and more new customers coming up that are not just mobile first, they're mobile only. 1 billion people were mobile only in 2012. By 2020, half of the world is going to be mobile first or mobile only. But this chart, I think, tells it all. Millennial smartphone behavior. I've got a 15-year-old son and an 11-year-old daughter at home. I can independently verify these numbers. 87% of millennials say my smartphone never leaves my side, day or night. It never leaves their eyeballs, right? 80% say when I wake up, the first thing I reach for is my smartphone. 78% say I spend more than 2 hours every day using my smartphone. 60% says in the next 5 years, I believe everything should be done on a mobile phone. Desktop websites to them are the exception, not the rule. Mobile first indeed. Interesting times we're living in, huh? So, this leads us down a path to offline first. And again, the reason I set these up as hashtags is because we're almost seeing the history of rallying cries over the last couple of years. I was standing up here in front of you several years ago saying, responsive web design, we all need to learn responsive web design. And you did, right? Which was a good thing. And now I've been saying mobile first for the past couple of years. Trust me, this is really important. Now, this is my rallying cry this year. It's not important just to be responsive and mobile first. We need to support offline. This is not optional. Because we just figured out that if millennials are expecting the whole of their web experience to be done on mobile phones, well then, we're living in a disconnected and battery-powered world all of a sudden. And I really want you to consider this, that my entire life, my entire professional life, close to 30 years now, has been dealing with something that has 101 keys and a mouse and a power connection. It's always on and it's always connected. When is the last time you sat down at a desktop computer and you didn't have an internet connection? You say, I can't use this, it's broken, right? That's our expectation. Always connected, always on, infinite screen size, infinite disk space, infinite RAM and CPU. Our reality is disconnected and battery powered and tiny screens and constrained resources. And that's entirely antithesis of what we've been doing all this time. So we can't keep building desktop apps. We simply can't. That's what the mobile first was trying to get us to understand. But I think offline first is a much better rallying cry, because that really explains to you. On the desktop, if you're offline, they're like, what does the web even mean if you're offline? Yeah? But on smartphones, we get offline and online all the time. We go into airplane mode all the time. If you're an AT&T customer, you lose the internet even if you're not in airplane mode, right? Yeah. So we are on tiny, disconnected devices. How many of you are using GitHub right now in your organization? Is GitHub offline first? Absolutely it is, isn't it? If you remember, we used to use Subversion, didn't we? And Subversion was much like the LAMP stack. You had a single source of truth, it lived on a server, and you just borrowed the truth temporarily on your laptop. If you checked out a Subversion branch and your laptop caught on fire, was there any impact at all? No, you were just borrowing the truth. GitHub is the antithesis of that. You have a full copy of the repo on your laptop, and you have the same copy of that repo on your laptop, and you have a copy of that repo on your laptop, and you access it through GitHub, which is just a shared version of that same repo. We are in a full multi-master mode that is fully distributed and fully synchronized. Do you trust GitHub? You must, we're all using it, right? So that model must be something we can trust. Have you heard of Couchdb? Couchdb is the GitHub of databases. Everything you know about GitHub applies to what you know about Couchdb. Every time you make a change to GitHub, when you do a git commit, it generates a hash, right? That is your unique identifier. That's how you roll forward and roll back. Guess what? Every time you edit a document, it gets a unique hash as well, so you can roll forward and roll back. Can you have multiple people working on a GitHub repo simultaneously? Absolutely, that's by design. When you merge, hopefully everything goes well. If Susie was working on the front end and Frank was working on the back end and they merge, they should be able to merge without a problem. The same is true with your data. The chances of someone logged into the Scott Davis account, editing the Scott Davis profile, editing the exact same field at the exact same time down to the millisecond is vanishingly rare, isn't it? But there can be lots of times where I go in and update a password, my wife goes in and updates my profile picture, and my kid goes in and adds things to my wish list, right? There's lots of examples here where that data can be successfully merged. Anything you can do in GitHub, we can do in Couchdb as well. Yes?
So you're going to tie down all this to the mean architecture?
Yes, so what we're doing is we're talking about databases right now. The M in mean historically has stood for MongoDB, and I love MongoDB, but that is a server-side only solution. So what I'm trying to take us down this path now is this third wave architecture and giving a persistent store that gives us an offline first experience. Does that make sense? Yeah. So not only does Couch give you HTTP and JSON right out of the box, it's got this replication protocol that gives us this offline first experience. Now you trust Git to handle syncing and all that. But you might be saying, this Couchdb, I've never heard of them. How can I trust them? Replication is a devilishly hard problem to solve. How can I be convinced that they solved it correctly? First of all, do you know what Couch stands for? It's an acronym. Couch is short for a cluster of unreliable commodity hardware. Couch is short for a cluster of unreliable commodity hardware. So it's baked into the name. This product was meant to be distributed and replicated out of the box. That was the whole reason it exists. But do you know what Couch is an open source version of? Lotus Notes. Lotus Notes. I was teaching Lotus Notes classes back in the 1990s. Lotus Notes nailed replication back in the 90s. Lotus Notes nailed identity, nailed security. How many of you use Lotus Notes as an email client? It was an awful email client, wasn't it? Yes, but what they were left with is a solution that was looking for a problem. It was so far ahead of their time, they're like, we've got this database. Oh, so it's columns and rows? No, these are documents. All right. Well, so I can do queries against it, right? Oh, yeah, you can do queries, but not SQL queries. Oh. What we do is replication. Well, why would I ever want that? Oh, I don't know. Let's say, like, hypothetically, you wanted to do some email, right? And so you had your email on your laptop and you're making some changes to it, and then you were on an airplane, and so you got off the airplane and you plug back in, and then all your email replicated. That sounds like a reasonable use case, doesn't it? And that's how Lotus Notes mail client came to be. But Lotus Notes has been doing replication since the 1990s. I would argue that Couchdb is less a database and more a replication API. Because where the story gets very interesting is when you turn around and consider that you might have some Couchdbs in a data center, some hanging out on mobile phones, some hanging out on desktops. That's where the replication story makes this incredibly interesting. Because just like you have CouchDB with a C, you also have PouchDB with a P. And PouchDB is a pure JavaScript implementation of Couch. Couch was written in Erlang. Pouch was written in JavaScript. And what this means now is we have a JavaScript API, a replication API, that basically has pluggable backends. If you run PouchDB on a Node.js server, you can back that replication API with a CouchDB or a CloudIntDB up in the cloud. You can back it with a MySQL database. You can back it with the file system. You can even back it with a pure in-memory representation. And that's just on the server side. On the client side, using Pouch now with a P, you can back it with an IndexedDB that's in your browser, or a web SQL DB that's in your browser, or local storage that's in your browser, or pure in-memory as well. So what we have now is a replication API with a rich set of options in terms of how you're going to back it up. But what this gives us is the offline first story. It means just like GitHub, You have a full fidelity database in your client and a full fidelity database up in the cloud somewhere, and we're synchronizing that state. And of course, it doesn't have to be the entire database. When it comes to Twitter, do you think Twitter is going to replicate everyone's tweets down to my client? No, probably not. But it'll do a wonderful job of replicating Scott's tweets to Scott, and Susie's tweets to Susie, and Frank's tweets to Frank. Yeah? Yes, sir.
So it has to integrate with offline first. If you have limitation. Yeah. So in this approach, what I see that it has a limitation that we cannot work with real-time data because if you say that, take the example of GitHub, will be working, if I'm working offline, then I'll be meeting a situation that I have to do merge and I'll be meeting a requirement of conflict or say some merge and all. So can you just name some other use cases where we can apply the same concepts like offline first?
I'm glad you ended the way you did, because that's what I was going to say. Yeah. If I had a heart monitor going, I don't think I have an offline story for a heart monitor, right? I want my patient to be alive, and so I want that heart monitor to be online and squawk when it goes off. So if I were building a heart monitor, this wouldn't be the right technology for this. Yeah, if I were a stock trader, and I always needed that most up-to-date information, this isn't going to be appropriate. If I have a search like a catalog or even a Wikipedia, I'm not going to replicate all of Wikipedia to you so you have an offline experience. But you know what I might do? As you read articles in Wikipedia, I might synchronize them to the client so the articles that you have already read, when you go offline, that's your offline first experience. Does that help? And really, I want to reemphasize this once again. I'm not saying that every new app that you build has to look like this. I've given you 3 options, and we're simply exploring this third option because it's the newest, and it's giving us new capabilities that we haven't previously had. Very nice. All right. So to wrap up here in the last couple minutes we have, progressive web apps. We've talked about HTML first. We've talked about mobile first. We've talked about offline first. And if you have achieved all of those, then we can begin discussing progressive web apps. All of those words are important, the progressive and the web and the app. Because many times when we're talking about mobile, we immediately think of native. We immediately think of iOS and Android. We immediately think of Objective-C or Swift or Java. Yeah? What's interesting is many of these native solutions, many of them are using web views internally. You know, Facebook bought Instagram for $1.1 billion. And when you pull up their native app and you get a 502 bad gateway in there, right? You say, wait a second, which is this? Is this native or is this a web app? And the dirty little secret in the industry, all of these native apps are in fact a thin native shell over web views. Twitter, Facebook, Instagram, LinkedIn, Uber, they're all serving up web content to their native app. Because this is an economy of scale. If you already built out this web app, you want to reuse it as much as you can. So these organizations are reusing their web content in their native apps. And this is interesting, because we're also in a situation where Gartner says mobile app adoption is maturing. Ooh, maturing, huh? Do you know what mature means? Dead. The average user downloads 0 apps per month. The average smartphone user downloads 0 apps per month. 42% of those apps are abandoned after the first time they're used. 77% of those apps are abandoned after being used 3 times. 95% of all smartphone apps are deleted within 90 days. That's a maturing market, isn't it? And what's interesting is we think that it's all app over here. This is North America saying this is our mobile app experience. But over here in Africa, we see that only 4% of their experience is native. That means that 96% is web. And if we take that same chart, this was a different article. This is what I thought was so fascinating. Same data visualized 2 different ways. Over here now, this blue bar is web traffic, native app usage. In Africa, we can see there's a big difference. In the Americas, it's about 50-50. In Europe, it's slightly skewed. Over here in the United States, we see there's our mobile web traffic versus native traffic. And this shouldn't surprise us because the 2 smartphone manufacturers are based in the US, Google and Apple. They represent over 98% of the market right now. And the way they monetize that is through apps and their app stores. Apple makes 30 cents on the dollar for every sale out of that app store. Even if I want to give my app away for free, I have to give Apple $100 to have a license, a developer key that I can turn around and publish. So they are making money hand over fist on native apps. And I don't begrudge them that at all. But that kind of behavior isn't reflected worldwide. And increasingly, it's not even viable behavior in the United States. When you have a 95% attrition rate after 90 days, that's not a sustainable market. So, what we have now are these things called progressive web apps. So they're apps just like native apps written in Objc or Swift or Java. But they're web apps. They're written in HTML, CSS, and JavaScript. And the progressive comes in because this is a very natural usage pattern. I might go to the GIDS website once and look and see Scott Davis. Oh, I'm never going to that website again, right? And that's fine. GIDS didn't require you to download an app, look once, change your mind, and uninstall it. But if you visit the GIDS website a second time and a third time, at some point you as a programmer, you can say, it seems like you're visiting us quite a bit. Would you like to install this website on your smartphone? And then literally what happens, at a button click, that content, like Schrodinger's cat, is transferred from the server down to the mobile phone, and when you go offline, you have the full fidelity experience. How nice would it be if we could pull out of our phones right now and navigate all that GIDS calendaring and all of the messaging and all the descriptions of the talks and everything like that. The same app, we're not talking about 2 apps like a www app and an iPhone app. One web, many screens. Progressive web apps are the way we can accomplish this kind of thing. And what's beautiful about progressive web apps is they're just based on standards. I only give one more talk. What is my talk about this afternoon? The HTTP2 standard. You can tell I kind of like standards, yeah? I don't like proprietary solutions. I like open, standards-based solutions. So progressive web apps are based on W3C, the World Wide Web Consortium specifications. Specifically, a progressive web app is a service worker with a web app manifest and almost certainly built out of web components. So let's examine this in just the couple minutes we have left. Service workers is a W3C spec. It's a working draft right now. But what a service worker is, wow, that's incredibly small. Apologize. What a service worker is a script that your browser runs in the background separate from the web page. I want to say that again. It's JavaScript that your browser runs even if you aren't on that web page. So if you went to GIDS.com, it could install a service worker that would be running as a daemon behind the scenes. Get this, even when you shut down your browser. So that gives us the ability now to do push messaging. GIDS could decide, oh, Scott Davis got sick, we're going to have to reschedule his talk. They could push that out. And even though it's a web app, you could get a notification because the service worker would be up and listening even if you aren't in your browser. GIDS can also push new content, not just the announcement, but the actual updated calendar. And they wouldn't even have to do that through Serviceworker if they were using Couchdb and PouchDB. They would make the change on the server, and those changes would be replicated down. Do you see this architecture that I'm laying out for you here? How it all works together that nicely? So service workers are a really interesting thing. The other thing that service workers have the ability to do is they intercept every click coming out of your web app now. So every time you click on a hyperlink, every time you click on an image, anything like that, you have a service worker that can intercept that and decide that if you're offline, maybe I'll serve up something out of local cache, but if you're online, I'll go and give you the freshest version of that data. So service workers are daemons that are always running, but the other key capability is they intercept all web traffic, so you have a really fine-grained control of the online as well as the offline experience. The other aspect of this is the web app manifest. And the web app manifest is really nothing more than a JSON file, but it's for installing your app. If you want to save that app and have access to it offline, you're going to want to create a web app manifest that gives your app a name and a description and an array of all the desktop icons you want. So it will support tiles for a Windows phone. It'll support icons for an iPhone. It'll support different glyphs for an Android phone. This is an array as it goes on. But really, this is a more full-fledged one. You can have a long name and a short name and a whole array of icons in there and display and orientation and theme and background and screenshots. And oh yeah, there's our service worker right there. So you can see we've got this lovely manifest that will give us everything we need to have an installable app. So the combination of service workers and app manifests really make this feel like a true platform application. Notice I didn't say web application or native application, platform application, because that's how I think of this. This is a web application. In fact, it's a progressive web application that starts as a website and converts to an application when the user opts in. So, what have we learned? Covered a lot of ground here. HTML first, mobile first, one web, many screens, offline first, progressive web apps. But most importantly, what we've learned is this mean stack is a wonderful architecture because it gives us the opportunity to describe one way we've done things in terms of LAMP, another way we've done things for the past couple of years. But this right here, I think, is what the web app development of the future is going to look like. Did you enjoy yourself? I did as well. Thank you so much for your time.
Thank you, Scott.